Hello, what's up? Malhai here, back with the Outta Syllabus, and as you know, I do not upload video every week now, but this is a requested video. So in this video I'm going to show you how you can create a push on off latch switch or push on off toggle switch or electronic toggle switch or whatever you call it. Basic concept is when you press the switch, the circuit turns on, and when again you press the button, basically the circuit turns on. So let's get started. So first of all, you have to understand what is a push button, okay? So there are a couple of switches. One of those type is normally toggle switch. Just when you turn it on, it turns on basically, and when you turn off, it turns off basically. And you found these kind of switches all over the place. Even on your main switchboard, when you press the switch, it turns on, and when you turn it off, it turns off. Basically, that's the normal switch what we are talking about. But there exists another kind of switch which is known as push button. So basically, this kind of switches, I should say, this kind of buttons, when you press them, it turns off, and as soon as you release them, it turns off. So basically, to turn the circuit on, to turn the switch on, you have to press the button continuously, and as soon as you release the button, the switch turns off. Now we are going to use this kind of switches and basically press it once to turn the circuit on and then press again to turn it off. So here are the components what you need to make the project. The first of all, you need a NE555 timer IC. Then you need two 10 kilo ohm resistors, 100 kilo ohm resistor. Basically, I am using here a potentiometer set to 100 kilo ohms to demonstrate, because I cannot find 100 kilo ohm resistor laying around. You also need a 1 kilo ohm resistor and a 1 microfarad capacitor, a LED of your choice, whatever color you want, and what we will be working with, the push button. So the parts list is provided in the description below. If you cannot follow this, then just go down into the description and see the parts list. For the circuit, this is the basic circuit diagram. I have also provided in the description below, but if you cannot find it or download it, then just take a screenshot from here. I'm basically going to show you how to make this thing on breadboard, and the easiest way I found of doing this is on Tinkercad. And physically, if I want to show you, then maybe that's the camera problem, the angle problem, or whatever that you call. And if I show that in the Tinkercad, it's pretty easy for you to understand. So that's what the thing I found out. That's kind of cool. See how it press it once to turn on, press it again to turn off. Do you see that? Turn off, turn on, turn off, turn on, turn off, turn on, turn off. Camera angle, it's terrible. Instead, I'm gonna fire up the Tinkercad and show you how to make the circuit on breadboard. That will be easier for you to understand and easier for me to tell. Let's get started. So here I am in my desktop. So let's open Tinkercad. So now we are gonna place our components. The first thing we need is a breadboard. The second one will be a 555 IC and resistors, as I've shown you. There you go. One will be 1 kilo ohm, that's perfectly right. Another will be 10 kilo ohms. We need another 10 kilo ohm to 10 kilo ohms. Oh yeah, 10 kilo ohms. And another resistor we need is 100 kilo ohms. There you go. The next thing we need is a push button. 1 microfarad capacitor. Sorry, it's a polarized capacitor.
16 volts. Let me turn this to 50 volts. The voltage actually doesn't matter however voltage you give through your battery, so that will be well below 16 volts. So let's keep it on 16 volts. Now that is 1 microfarad. That's absolutely right. So that actually, oh yeah, I need an LED. There we go. Now let's start the circuit. First of all, we have to place our timer in our breadboard. So as you can see, everything is labeled in there, but while you are doing it physically, nothing will be labeled. So basically you need to know need to know the pins. This is the notch, as you can see right here, and starting from here the pin number will be 1 2 3 4, then 5 6 7 8. The first thing we need to do is connect pin 2 to 6 and 4 to 8. This is the first step for all the 555 timer IC projects. Okay, so let's do it. Pin 2 to pin 6 and pin 4 to pin 8. Then we need to place a sorry guys, it's killing me. Now you have to place a 10 kilo ohm resistor in between pin 2 to pin 6. This is gonna be on pin 2. There is pin 2, and this will be on pin 6. Just connect it here. Change the color a little bit. So there is our first resistor. Okay, the second resistor will be between pin 8 and pin 6. So this is our pin 6. So we are connect another 10 kilo ohm resistor from pin 8 to pin 6, and this is actually our pin 6. So basically we are connecting the resistor between pin 8 and pin 6. So far so good. And the next thing we need to place is our capacitor. Where is our capacitor? Here it is. And the capacitor, the negative of the capacitor will be connected to pin 1. Okay, so this is the negative. As you can see, the real capacitors, you can see a patch in one side, and that side will be negative always. So here is my capacitor, and this is the negative terminal, as you can see. So I'm going to connect the negative terminal to pin 1. Okay, and take the 100 kilo ohm resistor now, and this is the 100 kilo ohm resistor, and connect it between the positive terminal of this capacitor. Let me rotate it. Positive terminal of this capacitor, which is this here, and another terminal will go to pin 3. There we go. Now we have our resistors connected. Now let's come to this push button right here. So one of the terminal of the push button will go to pin 2. So let's do it. This is our pin 2 and this is our push button. So I'm taking this terminal and putting this on pin 2. This is our pin 2. Let me change the color a little bit. There you go. So one of the terminals of our push button is connected to pin 2, and another terminal of the push button will be connected to the capacitor positive, which is our this pin right here. This one. This is the positive of the capacitor. So now we have our push button connected in place, and let's put the LED now. The positive of the LED will be connected to pin 3 again, because this is our output pin. As you can see, our output. Place this LED in here. Just have to rotate it. The positive of the LED will be connected to pin 3, which is our this, and the negative of the LED will be connected to the negative rail through this 1 kilo ohm resistor. There you go. Now we have to provide the necessary voltage. Now to do that, the negative will be connected to the pin 1 of this IC. As you can see, this is ground, so we are gonna connect this in here. Let's call it black, and the positive of the IC will be on pin 8. Now let's put it in here. Now that's basically completes our circuit. I have to provide power. Now to do that, I'm gonna use a power supply. Now let's use a 9-volt battery. The 9-volt battery, the positive will be connected to this, and the negative will be connected to the below terminal. Let's do that. So that completes our circuit, and hope you have understood the connections neatly, right? If you haven't, then watch this portion again. Let's sum up the connection for you. The first step you need to do is connect pin 2 to pin 6, then pin 4 to pin 8. That's complete our first connection. Then you have to connect pin 2 to one of the legs of those 10k resistors, and another leg of this 10k resistor will be connected to pin 6. That's complete our first resistor. The second resistor will be from pin 8 to pin 6 again. Then we have to connect our capacitor. The capacitor negative will be connected to pin 1, and the positive will be connected to pin 3 through a 100 kilo ohm resistor. Then we need to connect our push button. The push button will be connected to pin 2, and another terminal will be connected to the capacitor positive, like this. And then we need to place our LED, and for the LED, as we know, the third pin is output, so the positive of the LED will be connected to the pin 3, and the negative of it will be connected to ground through a 1 kilo ohm resistor right there. Then you need to bias your IC. To do that, connect pin 1 to ground and pin 8 to your positive of your battery. Then place the battery. 9-volt battery is recommended, and there we go. Completes our circuit.
So this is basically it, guys. Hope you have understood whatever I have shown you. There is a possibility of some troubleshooting. Here are some quick tips how to troubleshoot. If your circuit turns on normally when you press the button, but doesn't turns off when you press the button again, and when you remove the power source and plug it again, it works. But like before, when you press the button once, it turns on normally, but when you press the button again, it doesn't turns off. As you can see, I'm providing 4 volts through my lithium ion battery, and see, once again, 3, 2, 1, there you go. See, it turns on normally, but as soon as I press the button, it doesn't turns off, and that is because of 4 volts. So the problem for this is the power supply itself, guys, and you need at least 5 volts of power supply. I recommend using 9-volt batteries, because that is gonna work like charm if that is fully charged. Because in my previous video I've told you 9-volt carbon zinc batteries are just a piece of shit. Do check that out if you haven't yet. So that's gone, and the next thing, well, there is still a problem in my circuit, and when I just keep my finger close enough, it turns off automatically. See, that is because of the static sensitivity, and just your finger is acting like a conductor, and it's conducting the electricity. So instead I am using this plastic button screwdriver to switch it on, and switch it off. So that's all for today. Hope you have understood whatever I've shown you, and if you like this video, give it a thumbs up, thumbs down for the opposite, and do subscribe if you haven't yet. Consider supporting me on Patreon to keep the show going and spread the word about this channel. And this is Malhari, you're watching Outta Syllabus, and for today I'm signing off.